Hi guys, let's take a look at the actual survey that we looked at in class today. So here's an example of a survey from a female. She indicated she buys lunch typically. She spends about $3.50 and she uses the main line. So that's her typical lunch behavior. What I want you to realize is there are two kinds of variables that we're going to study in this class. The first kind of a variable is a categorical variable. So for instance, a categorical variable is simply an example of a label that a subject is using to describe themselves. So this person circled female. That is the label that they have used to describe themselves. Same thing, that subject is describing themselves here by choosing a label. They either typically buy, they bring, or they don't eat lunch at school typically. The other kind of variable is a quantitative variable. So a quantity being a number. So here now the subject, since they buy their lunch typically, about how much do they spend each day, they are giving me a quantity that they are using to describe their behavior. In this case, they indicated $3.50. So now sometimes just because the variable that you are collecting has a numeric value or a quantity doesn't mean that it has to be a quantitative variable. So for instance, take a look here. If this person had indicated they typically brought their lunch, I would have asked them to indicate how many times per week they bring fruit. Well, so understand there are only 6 possible answers: 0, 1, 2, 3, 4, or 5 times per week when they bring fruit. Well, but understand if they list a 5, what they're really saying is they always bring fruit. So they're choosing the label always. If they choose a 0, they're saying that they never bring fruit. There are, if you will, 6 possible numbers that they could have used to describe their behavior when it comes to bringing fruit typically on a lunch day. So the idea being here, I can use numbers in order to describe those behaviors, but those numbers are just like a label. So it's the same thing as thinking about sophomores. Sophomores can also be described as being in grade 10. So that number 10 really isn't a quantity, really it's a label. It's the same thing as saying a sophomore. If you're in grade 12, yes, I know that grade 12 represents a quantity of years that you have been in school, but we can replace that 12 with the term senior. So really the 12 is just a label, just like the word senior is a label. So a categorical variable is a variable where we can assign a label to behavior. So a quantitative variable is a variable where we are describing that behavior by using a numeric quantity, in this case, like for instance, a price. So going back to the handout then, the amount of money spent at lunch. The amount of money spent at a lunch line, that's a quantitative variable, but the other variables here, even the fruit question, really, we can think about these as categorical variables. categorical. Categorical variables. And again, why are they categorical? By a category, we simply mean a label. A label is being chosen that best describes that subject. A label or category is being chosen that best describes that subject. So before we actually look at the data from our survey, we're going to look for an association between gender and lunch behavior. Lunch behavior being, do you buy or bring, or do you choose not to eat lunch while you're at school? So ultimately what we're interested in is gender associated to lunch behavior. So in other words, if I knew someone's gender, would that help me to, if you will, predict their lunch behavior? So let me give you the data from this particular class. So in this particular class, for the females, there were 9 females that buy lunch typically. There were 12 that bring their lunch typically, and there were none in this class that don't eat lunch at school typically. For the males, 4 buy their lunch typically, 9 bring their lunch typically, and again it was 0. None of them don't eat lunch at school. So that's the raw data. Let's total it up first. So the 9 and 12 is 21. There's a total of 21 females. The 4 and 9 is 13. There's a total of 13 males. And the females and the males together make the class total of 34. So I can also get that same 34 by looking at the row totals. So 9 and 4 makes 13 students which buy. 12 and 9 makes 21 students which bring, and there aren't any that don't eat lunch at school. So again, that also makes for a total of 34. That 34 represents the total of the table overall. So in order to make our comparisons, look, you don't want to just compare counts. If you look at the counts right here, the 9 is bigger than the 4, and the 12 is bigger than the 9. But what's interesting is there are fewer males than there are females, so you really don't want to compare the counts. What you want to compare are percentages. So be careful, we have to use percentages in order to control for the different number of females and males. So let's start by calculating the percentages that use the totals. So in total, 13 out of 34 students, so you could write that as 13 out of 34, but really I just want this as a decimal or as a percentage. That's about 38% of students buy. So the 21 out of 34, if you turn that into a decimal and then into a percentage, you get 62% of students which bring their lunch, and 0% don't eat their lunch at school typically. So this is a calculation that's done outside the table. It's called a marginal distribution because it's almost written in the margin far to the right of the table. M-A-R-G-I-N-A-L. That is a marginal distribution. So we're looking at marginal distributions when we're looking at the totals. So same thing here. 21, I can think of that as 21 out of 34. So that's about 62% of the class is female, and again, 13 out of the 34. So that's 38% of the class is male. So again, that's considered a marginal distribution because it's a percentage or a calculation that's done on the edges of the table, around the edges or around the margins of the table. But really, if we're interested in looking at the association between gender and lunch behavior, what we want to do is control for the different numbers of students that are classified female versus male. So what we really want to do is in here, we want to calculate percentages based on the total of females. So under the condition that someone labels themselves female, what's the likelihood that they buy, bring, or don't eat their lunch at school? Same thing, we can calculate those same percentages for males, and in so doing, we can control for the difference in the sample size. So notice 9 out of 21 females buy their lunch. So 9 out of 21, that's 43%. So 12 out of 21 bring their lunch, that's 57%. And of course, it's 0 out of 21 or 0% don't eat their lunch at school. So for the males, we have a different size. 13 is the size of the, quote, if you will, sample of males. So 4 out of 13, that's 31%. So 31% of males buy their lunch. So that leaves us 9 out of 13, that would be about 69% bring their lunch, and again 0% that don't eat their lunch at school. So notice, it's important to compare percentages, not counts. So notice the count of females that bring their lunch, there are 12 females that bring their lunch, there are only 9 males that bring their lunch. But when you compare the percentages, males tend to favor in this class bringing their lunch. A larger percentage of males bring their lunch, 69%, compared to females that bring their lunch. That would be 57%. So here, 43% of females buy their lunch, 31% of males buy their lunch. So if I want to compare lunch behavior, the idea being here, if I know gender, so let's say I were to randomly choose a male in this class, I can see here that from the data, males tend to favor bringing their lunch over buying their lunch in this class. So I would tend to say that the male, if I just randomly picked one, he's probably someone that brings his lunch to class. Now, That's about a third of the time males buy their lunch, about 2/3 of the time they bring their lunch. But the idea being, I can see here by comparing the percentages that males tend to favor bringing their lunch. Whereas for the females between the two genders. Now notice I see within females, females also have a larger percentage that bring their lunch, but by comparing the two genders, females 43% buy their lunch versus males only 31% buy their lunch. So of the two genders, females tend to buy their lunch more than males do, and males tend to bring their lunch more than females do. So that's probably the best conclusion that you could draw here. So is there an association between gender and lunch behavior? I would say yes. So we'll start with buying. Females tend to buy lunch more often than males. And when we say more often, the reason that we can say more often is because of that comparison. 43% of females buy their lunch compared to only 31% of males. So you could also say this: males tend to bring lunch more often than females. Again, the reason we're saying more often, that's because the percentage is higher. For males, 69% of them bring lunch. It's 57% of females that bring lunch. So if what you're trying to do is compare between the genders, then you want to compare these percentages to one another. For the buyers, female to male percentage. For the bringers, the female percentage and the male percentage. That's the comparison that we're interested in here. Although in general, if you ignore gender, so we are specifically trying to find an association with gender. If you ignore gender, overall, I can see that in both cases, females and males, both of them prefer to bring lunch, but I really already knew that, because if you ignore gender, you can just go out here and look at the marginal percentages. I already knew that overall, 62% of students in this class, whether they're male or female, they bring their lunch. So another way to compare the genders is you could just make a bar graph. This is not a very fancy or complicated method. So on the horizontal axis, I'll put gender. So I could put females and males. So this is gender down here. And then on the vertical axis, we're going to work with percentages. So we'll go up to 70%. I'll go in units of 10%. So there's 10%, 20%, 30, 40, 50, 60. There's 70%. So I'll just make a bar for each of the percentages. So for females, we have about just a little over 40%, about 43% buy. So I like to label it. This is buy. I'll put a 43% up here. I'm just getting that out of my table from above. So it's nearly nearly 60%. It's just a little less than that. 57%. Those are the bringers. And then it's 0% that don't eat. Again, if we simply wanted to represent the data graphically, a bar graph is probably the simplest way to represent our percentages. So for the males, it's 31%, 31% that buy. It was almost 70%, so 69% that bring. And then again, like for the females then, 0% don't eat. So all I've done here is make a graph that takes the same data from the table and it just organizes it. So I can see here comparing the genders, the bar for buying is higher for females than for males, 43% compared to 31%. And the bar for bringing, it's higher for males than for females, 69% compared to 57%. But the idea is we're trying to make a comparison between the genders. And when we're working with individual genders here, these are called conditional distributions. So these percentages are conditional, Conditional, conditional distributions. So the idea being we are looking at our percentages, but separately under the condition that we're only looking at the females to calculate our percentages, and then also separately under the condition that we look only at the males.